Hello everyone, welcome to AFS Hackers. I'm Afshan. In this video, I'm going to walk you through the pre-security learning path of TryHackMe. So in our previous video, we have already completed the learning cybersecurity room. In this video, we are going to learn the network fundamentals. So let's start with what is networking. So the task one is what is networking. Networks are simply things connected. For example, your friendship circle, you are all connected because of similar interests, hobbies, skills, and so on. Networks can be found in all walks of life, like a city's public transportation system, infrastructure such as national power grid for electricity, meeting and greeting your neighbors, postal system for sending letters and parcels. But more specifically, in computing, network is the same idea, just disparate to technological devices. Take your phone as an example. The reason that you have it is to access things. We will cover how these devices communicate with each other and the rules that follow. In computing, a network can be formed by anywhere from two devices to billions. These devices include everything from your laptop and phone to security cameras, traffic lights, and even farming. Networks are integrated into our everyday life, be it gathering data for the weather, delivering electricity to homes, or even determining who has the right of way at a road. Because networks are so embedded in the modern day, networking is an essential concept to grasp in cybersecurity. Take the diagram below as an example. Alice, Bob, and Jim have formed their network. We will come onto this a bit later. So this is Alice, Bob, and Jim. Networks come in all shapes and size, which is something that we will also come on to discuss throughout this module. So answer the questions below. What is the key term for devices that are connected together? So that is network. Submit the answer. Yes, it is correct. Task 2 is what is the internet? Okay. Now that we have learned what a network is and how one is defined in computing, just devices connected, let's explore the internet. The internet is the internet is one giant network that consists of many small networks within itself. Using our example from the previous task, let's now imagine that Alice made some new friends named Zen and Toby that she wants to introduce to Bob and Jim. The problem is that Alice is the only person who speaks the same language as Zen and Toby. So Alice will have to be the messenger. So here's Zen, Toby, Bob, and Jim. And Alice know the same language. And the Alice is the only person who speaks the same language as Toby and Zen. Because Alice can speak both languages, they can communicate to one another through Alice, forming a new network. As you guys can see, this is a new network. Sorry, this is the new network. The first iteration of the internet was within the ARPANET project in the late 1960s. This project was funded by the United States Defense Department and was the first documented network in action. It wasn't until 1989 when the internet as we know now it was invented by Tim Berners-Lee by the creation of the World Wide Web. It wasn't until this point that the internet wasn't used as a repository for storing and sharing information like it is today. Let's relate Alice's network of friends to computing devices. The internet looks like a much larger version of this sort of diagram. Like as you guys can see, this is a network 1, this is network 2, and this is a network 3, and they all are connected to the internet. Previously stated, the internet is made up of many small networks all joined together. These small networks are called private networks, where networks connecting these small networks are called public network or the internet. So to recap, a network can be one of two types, a private network or a public network. So devices will use a set of labels to identify themselves on a network, which we will come onto in this task below. So who invented the World Wide Web? That is Tim Berners-Lee. Let's copy it and paste it here. Submit the answer. Yes, it is correct. Task 3 is identifying devices on a network. So let's see. To communicate and maintain order, devices must be both identifying and identifiable on a network. What use it is if you don't know whom you are talking to at the end of the day? Obviously. Devices on a network are very similar to humans in the fact that we have two ways of being identified, that is our name and our fingerprints. We can we can change our name through Deadpool, but we can't, however, change our fingerprints. Every human has an individual set of fingerprints, which means that even if they change their name, there is still an identity behind it. Devices have the same thing, two means of identification, with one being permeable. These are two means of identification, that is an IP address and a media access control, that is MAC address. Think of this as being similar to a serial number. So IP addresses, briefly, an IP addresses or internet protocol address can be used as a way of identifying a host on a network for a period of time, where that IP address can then be associated with another device without the IP address changing. First, let's split up precisely what an IP address in the diagram below. So 192.168.1.1 is an IP address. An IP address is a set of numbers that are divided into 4 octets. So these are the octet, and the IP address is a set of numbers that are divided into 4 octets. So this is octet number 1, 2, 3 and octet number 4. The value of each octet will summarize to be the IP address of the device on the network. This number is calculated through a technique known as IP addressing and subnetting. But that is for another day. What's important to understand here is that IP addresses can change from device to device but cannot be active simultaneously more than once within the same network. And IP address follow a set of standard known as protocols. These protocols are the backbone of networking and force many devices to communicate in the same language, which is something that we all come onto another time. So however, we should recall the devices can be on both a private and a public network. Depending on where they are will determine what type of IP address they have, a public or a private IP address. A public address is used to identify the device on the internet, whereas a private address is used to identify a device amongst other devices. So take the table and screenshot below as an example. Here we have two devices on a private network. Like this particular device is on the private network. The IP address is 192.168.1.77. These two devices will be able to use their private IP addresses to communicate with each other, like the private IP addresses. However, any data sent to the internet from either of these devices will be identified by the same public IP address. Public IP addresses are given by your internet service provider at a monthly fee. The public IP address is same, but the private IP address is different. So as more and more devices become connected, it is becoming increasingly harder to get a public address that isn't already in use. For example, Cisco, an industry giant in the world of networking, estimated that there would be an approximately 50 billion devices connected on the internet by the end of 2021. Enter IP address version. So far, we have only discussed one version of the Internet Protocol addressing scheme known as IPv4, which uses a numbering system of 2 is to 32 IP addresses, that is 4.29 billion. So you can see why there is such a shortage. So IPv6 is a new iteration of the Internet Protocol addressing scheme to help tackle this issue. Although it is seemingly more daunting, it boasts a few benefits, that is support up to 2 is to 128 of IP addresses that become 340 trillion plus IP addresses, and resolving the issue faced with IPv6 and more efficient due to the new methodologies. And this screenshot below compare both an IPv6 and IPv4 addresses. So here is an IPv4 address and here is the IPv6 address. Let's learn about MAC addresses. So devices on a network will all have a physical network interface, which is microchip board found on the device's motherboard. This network interface is assigned a unique address at the factory it was built at, called a MAC address or media access control address. The MAC address is a 12-character hexadecimal number, a base 16 numbering system used in computing to represent numbers, split into twos and separated by a colon. These colons are considered separators. For example, A4 colon C3 colon F0 colon. This is the example of the hexadecimal number with colon. So the first 6 characters represent the company that made the network interface, and the last 6 is a unique number. As you guys can see, the starting 6 letter denotes the vendor who would build the network interface, in this instant Intel, and the last 6 digit is unique address of the network interface. However, an interesting thing with MAC address is that they can be faked or spoofed. Faked in a process known as spoofing. The spoofing occurs when a networked device pretends to identify as another using its MAC address. When it occurs, it can often break poorly implemented security design that assume that devices talking on a network are trustworthy. So we can spoof the MAC address. Take the following scenario. A firewall is configured to allow any communication going to and from the MAC address of the administrator. If a device were to pretend or spoof this MAC address, the firewall would think that it is receiving communication from the administrator when it isn't. Places such as cafes, coffee shops, and hotels alike often use MAC address control when using their guest or public Wi-Fi. This configuration could offer better services, that is, a faster connection for a price if you are willing to pay the fee per device. The interactive lab attached to this task has been made to replicate this scenario. So this is a practical. So let's see what is a practical. Uh, the, the interactive lab stimulate a hotel Wi-Fi network where you have to pay for this service. You will note that the router is not allowing Bob's packet blue in a blue color to the TryHackMe's website and is placing them in a bin, but Alice packets green are going through the fine because she has paid for Wi-Fi. Try changing Bob's MAC address to same as Alice to see what happens. Deploy the interactive lab and proceed to answer the following questions below. So first let's see the questions. So the first question is, what does the term IP stand for? That is Internet Protocol. Let's just write it here, Internet Protocol. Submit the answer. Yes, it is correct. What is each section of an IP address called? That is octet. Octet. There are 4 octets. How many sections in digit does an IP address have? That is 4 octet or 4 section. Submit the answer. Yes, it is correct. What does the term MAC stand for? That is Media Access Control. Media Access Control. Submit the answer. Yes, it is correct. Deploy the interactive lab using, okay. Let's find out the flag. Okay, so Alice has already paid for the Wi-Fi service, and here is the MAC address. Let's copy it, and okay, our request is going to this bin, as you guys can see. So let's change the MAC address as Alice MAC address, and let's click on this request site. And yes, we have got our flag. You got on TryHackMe. Let's copy it and paste it here. Submit the answer. Yes, it is correct. Okay, so let's start with the task 4, that is ping ICMP. So ping is one of the most fundamental network tools available to us. Ping uses ICMP, that is Internet Control Message Protocol, packets to determine the performance of a connection between devices. For example, if the connection exists or is reliable. So let's click on this view site button first and now read the theory. So the time taken for ICMP packets traveling between devices is measured by ping, such as the screenshot below. Like, as you guys can see, the time is display here. This measuring is done using ICMP's echo packet and then ICMP's echo reply from the target. So remember this particular line. And pings can be performed against devices on a network, such as your home network or resources like websites. This tool can be easily used and comes installed on operating system such as Linux and Windows. The syntax of a simple ping is ping and the IP address. We have already done this exercise in our Hack the Box challenges. We always try to see like the machine is up and running. So we'll use this particular command, that is ping and the IP address. So let's see this in action in the screenshot below. Here we are pinging a device that has the private address of ping informs us that we have sent 6 ICMP packets, all of which were received with an average time of 5.3 seconds. Like, this is the time and this is the IP address. Now you are going to do the same thing to the ping address of 8.8.8 on the deployable website. In this task, pinging the correct address will reveal a flag to answer the following question below. So what protocol does ping use? So that is ICMP protocol. Submit the answer. So what is the syntax to ping? This is the IP address. So let's try to ping. So this is the syntax. Let's submit the answer. It is correct. And what flag do you get when you ping 8.8.8? So it is an IP address. So let's write this IP address here. Send the ping request. And yes, we have got our flag. I ping the server. Let's copy it. Paste it here. Submit the answer. Yes, it is correct. So we have completed the task 4. So the task 5 is continue your learning intro to LAN. Okay. So we have successfully completed this what is networking room of TryHackMe. So I hope you like this video, guys. If you did, then share this video with your friends and colleagues. And yes, don't forget to subscribe to my YouTube channel. We'll see you guys in my next video. Till then, take care and keep hacking.